Okay, it's 1 o'clock Central Time. It's Tuesday. That means it's time for our clinic. Welcome, everybody. I checked earlier that there weren't any questions for today, and I learned that Elena and John Mainzer did a fantastic job during my absence, and I hope nobody's disappointed. We can bring them back if there's a lot of demand and you enjoy their way of presenting things more. Nevertheless, okay, let's just go back to the way we used to do things. I didn't see any questions. I believe that Elena answered that question. So I will find out from her and yeah, post the answer here. Last week's highlights, or maybe before I go there, for those who are attending here today, are there any questions? Any questions that you want to bring up right now or bring up later? I'll pause several more times. No? Okay. Last week's highlights, and I actually, for the forum, I went through the last 3 weeks because I missed all that, and I caught up on that this morning. Announcements, I think there are 2 announcements. Number one, the HUG 2021 agenda was posted. I have the link here. Remember, it's going to be between October 12th and 15th, every day, 9 o'clock in the morning until 1:30 in the afternoon, Central Daylight Time. And yeah, it's a very interesting agenda, as you will see if you go to the agenda. Many different topics, great applications, great community contributions. So yeah, I can't wait to see all that. The second one is there was a very interesting webinar last Friday, I believe. Dana Robinson and Joe Lee talked about new features in the HDF 5.1.13 release, and the recording and slides are available now. So the recording is on the YouTube channel, and then the slides are available as PDF, and I included both links here. I'll switch to the forum, but before I do that, I'm going to pause again and ask, are there any questions about these topics or anything else, anything related to HDF, your applications? No? Okay, then I'll move on. Forum. It's always exciting to sort of, after a few weeks of absence, to sort of go back and see what was discussed, what new topics were raised, and so forth. So here's what stood out to me. Number one is, okay, there were actually 2 posts asking, users were asking that they would like to change the email address associated with their registrations for the forum. And yeah, I was just bouncing that question off to Lori. And Lori, maybe do you want to say something right now about that?
Sure. Well, nothing real conclusive. I want to look into that with our IT person before I change email addresses, because it's controlled by a separate entity, Auth0, and I don't want to disconnect accounts because there's the forum and our website. So it's kind of, we have kind of a messy system, and I want to talk to IT before we do anything, but I've sent a meeting request to get that going.
And we'll probably do an experiment first before we
on some
let
pretend
users
accounts
do this. And yeah, it's probably not a huge number of users, but yeah, if you switch companies or you want to associate that registration with a different email address and so forth, that's perfectly understandable. And yeah, we'll look into that. Okay. Then somebody was asking about retrieving property lists from objects. That's pretty straightforward, although it's somewhat inconsistent for different objects. But basically, the first thing you have to keep in mind, there are different kinds or flavors of property lists. There are what we call access property lists and creation property lists and transfer property lists. And typically for objects, so that is groups, data sets, and committed data types. And in this case also files, although files I think in the official nomenclature are not considered objects, but it includes files. Data set transfer properties actually apply only to write and read operations, so they are not really directly associated with files. And then attributes. There are attribute creation properties and attribute access property list. But again, depending on which vocabulary you use, attributes are usually not considered HDF5 objects, but sort of auxiliary things, user level metadata that you can associate with objects. Then, okay, so once you have that, then there are typically, and I pointed it out in my reply, for the particular object type, like data sets, there is typically an H5 for data sets D, get underscore, and then there would be a get underscore create plist, or an H5D get underscore access plist. And that would give you a handle to a property list, access property list, creation property list, and so forth. And then you can call the appropriate get method on that property list handle to find out, for example, I think the user in this case was concerned specifically about, given a data set that's chunked, I would like to know what is the chunk size of that data set. And so, yeah, you would do an H5D get create plist because the chunk size is what we call a creation property of a data set, something that's number one gets stored in the file, and number two, once a data set is created with a certain chunk size, that chunk size is kind of baked in, it cannot be changed anymore. So yeah, you would do H5D get create plist, and that would give you a handle to the data set creation property list. And then on that, you would do an H5P get chunk. There is an H5P get chunk. So when you create the data set, you would set the chunk size on a creation property list with H5P set chunk. And so in this case, you go the other direction. You use H5P get chunk, and that would give you the shape or the extent of the different dimensions in case this is a multi-dimensional data set. And that's it. And it works the same way for other properties, including access properties. The difference, however, being that only creation properties are really stored in the file. Various access properties and also transfer properties, they're really just transient. They exist as long as the object or that operation is in memory and are not stored in the file. And then don't forget, if you do that, if you do, for example, an H5D get create plist, that later you close that handle, that you close that property list with H5P close, because otherwise you get resource leaks. So it's what I call the Powell principle, which says if you acquire a resource, you own it, meaning you are responsible for the memory, and you have to abide by this open or copy or create close handle discipline. Okay, that was property lists. Another user had an interesting question. He was trying to call the HDF5 library from a dynamic plugin, presumably it was in the context of H5 repack, I believe, call the HDF5 library from a dynamic plugin, and it turned out that that was possible only if he used the shared version utility. And in addition to that, he had to link his plugin against the HDF5 library. And he was wondering why that is, and if that was necessary, if there was another way. And interestingly, he also created a GitHub issue where he sort of described a little bit what was happening and so forth. And Alan replied to that. And yeah, this is something we see sometimes. Number one is, yes, so that mechanism of loading a plugin is based on a standard function, DL open, or under Windows, there's a similar function where you can open a shared library and then introspect what kind of symbols are available in that shared library, and then sort of call the function that you're looking for, see if it's there, and then if it's there, call the right function. And that requires that, and then in addition, if you want to call the HDF5 library from your plugin, then of course you need to link to that at build time. And this is also, as the user points out, this is kind of an odd thing. You might say, well, why is it necessary to call the HDF5 library from a plugin? And this is more a topic for discussion, not here today, but one camp sort of argues and says, well, in my plugin, for example, my filter plugin, my compression, I might be interested in the element type that compression is applied to, the chunk size, and a few other properties, and I use the HDF5 library. Now it's debatable. You could say, well, what are the ways of getting that information to the plugin? And so you could then argue and say, well, if you look at the callback interface, for example, for filters, you don't see arguments for things like element type and whatnot, and people are in a way forced, or in a way coerced into using HDF5 library functions and then call the library. But of course, the other camp, or on the other hand, you could argue, well, as part of this plugin, you can pass arguments, albeit, and I think we talked about that 3 weeks ago, you can pass through unsigned integers, through an array of unsigned integers, you can pass certain information to the plugin, and you could convey things like element type or chunk size and so forth through that. Sure, I would give you that. That's rather tedious. Then you have to come up with a way, well, how do I represent an element type as an unsigned integer, or chunk size as an unsigned integer? Or you do you do it the sneaky way, where you take that element type as an HDF5 handle, although then you would still have to call into the HDF5 library to decode, to determine the type class and so forth. So it's a little messy in the sense that in some cases you can argue and say that is that inclination to call the HDF5 library from a plugin is there because the API is outdated, clumsy, or there are use cases now that when these APIs were created, these callback interfaces, people just didn't think about certain use cases. So that's a discussion to be had. For example, one of the more recent examples where this came up, and actually at the HUG meeting, I think we will talk about that, is, for example, Lucas's computational storage, or HDF5 user-defined functions, as he used to call it. He ran into issues like that, where when you treat a particular chunk, you actually don't know where does that chunk live in the data space and so forth. And then again, there is a discussion that you can have. On the one hand, you can say, well, the filter plugin has to be deterministic in the sense that it should only depend on the data that are being presented to the filter function, be it compression or encryption or something. So in a way, it should be stateless, because if it weren't stateless, then that would be kind of weird. That, for example, it might depend on, if you have the same data bit for bit, depending on when you filter the data, you might get different results, which would be, I'm not saying there aren't conceivable applications for something like that, but it would sort of introduce an additional strange state for which there is actually in HDF5 at the moment no place to maintain that state of the compression plugin. So for example, if you think about compression algorithms that have a learning ability built in, does that mean that the same chunk containing the same data set elements, if the learning then has progressed a little bit, will your algorithm, your plugin, compress that chunk differently after it has learned more about sort of the data distribution and so forth in your data set? While that is certainly possible and whatnot, it's not something that is supported at the moment with the HDF5 filter API. And then the question is, well, is this something we should be supporting? Is this really a common use case and so forth? So there are lots of interesting questions here. And I think, yeah, during the HUG meeting, we will have some time to sort of dig a little deeper here and get a sense of how many people are interested in that. And then there was another post about object timestamps, whether they are useful and so forth. So this is just when you create an object, a group, a data set, and so forth in HDF5, and then you use a function like h5o get info, one of the h5o get info functions, similar to a file system where you keep track of for a file creation time, modification time, access time, potentially. This implementation in HDF5 at the moment supports only the creation time, and so to my knowledge, yeah, the modification time and last access time were actually never implemented. And someone had a question about whether it is worthwhile maintaining those, because if you, for example, look into reproducibility questions, for example, bitwise or bit for bit reproducibility, that's an issue at a different time. You run the same program and sort of nominally have the same data, but if you do a bit by bit comparison, then you do not get the identical data because the timestamps are different. But then, of course, there was at least one user who expressed it or showed a use case where that was important, but he also pointed out that that if we were to change the defaults, at the moment the default is that the creation time is indeed maintained and stored in the file, but should we change in a major release, like in 1.14, for example, a default behavior and disable the tracking of the creation time, then it's important. It's certainly legitimate to make that change, but then also to clearly communicate that so that people who count on that being present and available, that they aren't sort of caught by surprise and then have a lot of issues to fight. And so those were the things that stood out to me. There were many other interesting topics related to HSDS and so forth, then also the table API and so forth, but that's my highlight. I'm going to pause here and just ask, are there any questions related to this or unrelated to this, to your applications around HDF5? No? Okay.
Yes, Gerd, yes.
Yeah, go ahead.
I just had a quick question on the object timestamps. I looked in the forum, and the last post in there, the person did have the use for it. But I was wondering, but his was a little bit more arcane, maybe, because he said they used it just to give additional information of the context of the data within the project. But what about the case of downstream processing using the timestamp just as a default ordering key? Does that go on?
Yes. So that's another use case. If you remember, let's say you do an iteration over links or an iteration over objects, then I think the default is actually, you caught me there. I think the default is lexicographic by name, but certainly as an alternative, you can also request iteration by object creation time order. And so, but I think you have to enable the creation of that creation time based index when you because that index is not being maintained by default. So I think you have to request that when you create the object already. So I think when you create the objects in a group, for example, you have to, as part of the group creation properties, I believe, you have to request to create an index by creation time. So if the default were to change that the creation time is not tracked by default, I think that wouldn't impact that necessarily, because when you create the group and you want to track things or you want to iterate in the future things by creation time, you have to do that explicitly already.
I see.
But I can look into that, yeah. But that's another good use case in the sense of iterating by creation order, yeah, iterating by creation order or visiting, or yeah.
Yes, because if on the creation side it's very deterministic, then that's useful. Then that people might be expecting it downstream. If it's being displayed by time, they would expect to see the same ordering for the same file, for a different file. So it's useful to have, I think, from that standpoint, which would seem to be a fairly common expectation.
Yeah.
Perhaps.
Yeah. No, I can definitely see that. And it's not, in this particular case, maybe useful or not is a little too harsh. It's not that one side is right or one side is wrong. It's just there are use cases on both sides. But then, unfortunately, since there has to be a default, the question is, which group can live, or sort of how many people can live with a. Although it's not democratic in a sense that the majority, what the majority can live with is what should be the default. But yeah, it's a discussion, and it might be a good thing to talk about also. But
it's good to know the point that you made about the creation time is it is distinct from the notion of enabling object timestamps. So that's a wrinkle that's worth noting there in that sense.
Yeah, and it's in a way, I think the whole timestamp issue. Well, for one, I think this came also up in this thread. It is a little bit unfortunate that that there is no proper time data type in HDF5. There was an effort at some point, but then it turned out not to be really portable. It was like a hot potato that was just dropped, and it was deprecated, and we don't talk about it anymore. It's sort of, yeah. But I think that problem hasn't gone away. It's and I could give other examples like Boolean or complex, that we don't have out-of-the-box support for those types, but timestamps, yeah, is just such a basic thing. But then if you speak with people in the HDF group, well, why don't you go back and fix it and or introduce a proper way of storing types in a portable way? Then people usually get defensive and they say, well, considering the user audience, there are so many different understandings of time out there that we don't want to get into that fight and so forth. But my argument would be in programming languages like in C++, for example, they have solved this problem. They have solved this problem in the sense that I'm sure the group of HDF5 users is a subset, quantity-wise, of users of C++, and so they are all happy with Chrono, with the Chrono library in the C++ standard that fits their or fits the timekeeping or time storing needs of a very diverse audience. Why can't we do something? Why can't we learn from that and do something like that?
Yes.
And so I think that's overdue. And it's just, yeah, of course, it's a matter of writing an RFC and getting funding and so forth. But I think, yeah, and because then that would maybe also take that timekeeping issue a little bit away from the objects and so forth. To be useful for applications, I think time should be at the level of a data type and so forth, rather than something that is sort of, well, yeah, inspired by what file systems do, but because of that also more limited or as useful or as limited as timestamps in a file system can be. Whereas if we had a proper time data type along the C++ Chrono, for example, then users could take advantage of that and use it like all other data types. And
yes,
in the definition of attributes or in the definition of data sets and so forth, to really, if they wanted to store something when they modified a particular element in a data set, for example, they could have sort of a mirroring data set of timestamps or something like that. And, anyway, okay, it looks like we're running out of time. Nevertheless, I'm going to quit, unless there are other questions, maybe before I jump the gun here. Are there any other questions at this point? If not, then I had prepared something, but I can come back to that next time, or you can look at it here. I wanted to say something about HDF5 references, and the idea basically being that there were some changes in HDF 1.12 where we extended the concept of references. So the idea behind references is, well, first and foremost, they are an HDF5 data type. So you can create data sets of this reference type, or you can create attributes of that reference type. And then the question is, well, what does such a reference represent? Well, pre-HDF5 1.12, the referents of such a reference were either data set regions, so you can think of that like a Boolean mask that you can superimpose on a data sets where certain elements are selected and others are sort of masked or blanked. And they could also refer to objects, so you can think of a reference like a pointer if you wish. And in HDF 1.12, this was essentially, well, the API was cleaned up, but also the reference were extended to include also HDF5 attributes, but also I believe, and actually I should check that before I say something wrong here and correct it next time. I believe the objects can also be in other HDF5 files. In the original object reference design, the objects had to be from the same file. And the main motivation behind that at the time was actually to support querying and indexing. The basic reason being that if you think about it, let's say you have some kind of querying language on HDF5, and if you think about a SQL query, it has sort of this closed worldview thing where if you say, well, the input to a SQL query is a relational variable, and the output of a SQL query is also a relational variable. So if you apply that analogy to HDF5, if you ask, well, what is the input to an HDF query? It is sort of an HDF5 structure, let's call it that. And what would be the output of that query? And in order to make that manageable, you can think of it, well, you have this HDF5 structure, this graph-like thing. The result of that query should be basically, well, yeah, you just select or remove, whichever way you want to look at, what's not in the result of that query. So for example, if you say, show me all the attributes that start with an A on this structure, it should be in a way sort of gray out or blank out all the attributes and objects that are not decorated with an attribute that starts with an A, and it should retain only those objects that have that are decorated with an attribute that starts with A. So that was one of the reasons or the motivation behind changing the reference design. And then I linked it here. We have a pretty good set of examples to describe the life cycle of these, but I'll come back to that next time because the old API was sort of a little clunky and unclear. I think the new API looks much better, but we are out of time, and thanks everybody for coming, and we'll be back next week here, and I hope to see all of you and more then. Take care. Bye.